Hey everyone, so I'm taking the current situation as an opportunity to finally learn the Godot engine. I've used Unity for the past 7 years and I have several ongoing projects where I can't really afford to switch engine. Still, I always wanted to take a look at Godot, so here we go. I will try to port my 2D Metroidvania Summit, a pretty big game which I've released earlier this year. Obviously, I won't port the entirety of the game, but I will use the assets and try to re-implement the basics as closely to the original as possible in Godot. I will also jump in headfirst, so I haven't seen any tutorials about Godot whatsoever yet, and I will try to figure out all of the stuff kind of as we go. Alright, so let's do this. So I've already downloaded the latest stable Godot version, which is 4.1. And the first thing that comes to my mind is how incredibly lightweight this is. The download alone was 60 megabytes and unpacked it's also only around 140 megabytes. Compare this to the around 5.2 gigabytes of Unity or the insane 50 plus gigabytes of the Unreal Engine. It kind of reminds me of Blender versus the old industry giants like Maya or 3ds Max. Okay, so I have opened up Godot Engine and I'm immediately greeted with the project manager, which seems to be similar to Unity's Unity Hub. So I can create a new project here and I have to enter a project name, which I will call Summit Godot, and a project path. And I can also create a new folder for the project, which I think I want. Yeah. So for renderer, I can select between Forward Plus, Mobile, and Compatibility, which seem to me that those are options similar to Unity's URP versus HDRP. Forward Plus seems to be the most advanced for 3D graphics. Compatibility, fastest rendering of simple scenes, OpenGL 3. I think I'm gonna go since it's gonna be a 2D game. Honestly, I'm not sure yet. Here it says the renderer can be changed later, but scenes may need to be adjusted, which is probably fine. But for now, I think I will go with the compatibility mode. And version control Git is also desirable. So let's hit create and edit. Okay, here we go. That was actually pretty fast. So here we have the Godot Engine Viewport. Here on top right away I can notice that we can switch between 2D and 3D mode. We also have a scripting tab. This seems to be a built-in script editor and an asset lib. This looks to be similar to the asset store or more like the package manager. I'm not sure. Okay, so let's go to the 2D viewport for now. So on the left hand side we have a scene tab where we can create a root node. Let's just create a 2D scene root node at first. Okay, yeah, and then it turns out to be, I think, the scene graph. And right below we have the file explorer. I assume these are all of the files that are included in the project. And on the right side we have the inspector, very similar to Unity's layout basically. And on the right side we have a node tab. Okay, this seems to list all of the functions that are available on this node. And a node seems to be similar to a game object, I guess, which in the inspector we can see has properties. It has a transform component. I guess we can call it component for now, with position, rotation, scale, and skew, very interesting, and a canvas item and a node. Okay, and we can add metadata here. Okay, not sure yet what this is supposed to do. Yeah, pretty familiar viewport, I would say. We have an icon SVG included here. Can we just drag it in here? Apparently we can. Which is interesting because if it's actually an SVG, a vector graphics file, that means that Godot is natively supporting using vector graphics, probably alongside of raster graphics, which definitely is a nice feature. Over here we have the play button, so let's just try it right away to hit play. And it says no main scene has ever been defined, select one. Okay, yeah, whatever, select current one. Oh, okay, so we have to create a scene first. Yeah, let's just call this main scene. I think the naming convention is slightly different in Godot, I've already noticed. I think the casing is something like that. Okay, so we have an empty window here. So apparently, oh, here I think the viewport is this one here, right? So let's try again. Yeah, okay. So we have our first sprite, I guess, inside the scene. Let's maybe first try to move around this little sprite in a straight line, I guess. I forgot to mention that there are currently 2 versions of Godot. One of them is with C# .NET support, which I thought as a Unity developer is probably a nice way into it. So I love the C# program language, and I heard the Godot native GD scripting language is pretty good as well, and probably better integrated so far. But I still would love to keep using C#, so let's just try how the integration works so far. I'm looking for some way to create a new C# script, basically, to move around this object. And over here in the inspector, I can see a script section, which is empty so far. Oh, perfect. New script. Let's just call this move sprite. Oh, naming convention. Okay, I can select the language, C#, inherits Sprite 2D. Okay, I can actually type stuff in here, or I can select a node where this is. So basically, I think that means the base class probably. Sprite 2D is probably gonna be fine if it's the default selection here. Class name NA, that's weird. Okay, let's just keep all of those here and hit create. Okay, and we are apparently by default using the built-in script editor. Let's just see for a moment how well C# is supported in here. Apparently not that great because nothing is really highlighted. Yeah, it looks like there isn't really any like IntelliSense or autocompletion. I guess for GD script it's probably far better, I would assume. Here no, there are not even basic autocomplete methods. So I will right away try to open this in another editor. I'm generally using Rider when using Unity. So let's see if I can manage to open up the script or the solution in Rider. So let's see what we have here. Project settings maybe? No, I think these are mostly related to the specific project. We need some kind of preferences or something like that. Tools, C#, create C# solution. That looks pretty good. Let's see what happens when we're doing this. Oh, okay. Okay, nothing happened, it appears. At least not here in the file system. Maybe we can inspect the actual file system. Do we have some? Oh yeah, open in file manager. Yeah. Oh, okay. And actually there is a C# solution. Yeah, we'll have to open this in Rider, I guess. I won't be using Visual Studio. Yeah, we have a very basic C# solution here with our move sprite file. And this already looks much better. I think, yeah, we have proper autocompletion now. I don't know if Rider supports the Godot scripting backend already well enough, but it seems that at least we have some basic highlighting and some basic autocompletion, so I think we should be fine. So yeah, let's try to move the sprite in a straight line over the screen. So we have 2 methods here, ready, which is called when the node enters the scene tree for the first time. So this seems to be the Unity's start. And the process method seems to be Unity's update, where we get past a delta time right away. So here in the process method, we will try to translate the position I think if we hit this dot, then we can see what our base class, our Sprite 2D offers. And here I can already see a position and then rotation, scale, skew. Yeah, so all of the properties of the sprite. So let's just focus on the position for now. And yeah, I think we can just go for position plus equals vector2 dot right multiplied by the delta multiplied by some speed. Let's just see if Godot has a similar way of handling properties and exposing them to the editor as has Unity. So I'll just create a public float speed with a default value of something like 5. Oh, okay, here we are using a double. Does this mean that the vectors are also using double? No, I don't think that should be the case. No, these are based on float. So why exactly is the delta time a double? I'm wondering. Yeah, whatever. Let's just cast it to a float. And okay, I think this should be fine. Let's go back to Godot Engine. The following files are newer on disk. What action? Okay, I have to reload them, I think. Yeah. Oh, okay, this is just because of the built-in editor. So let's switch over to our viewport. Okay, I don't see the speed property that I tried to expose here. So probably it works differently. Anyway, let's just try to start the game and see if anything happens. Oh, okay, I can also hit F5, which is nice. Building.NET project. Okay, interesting. Oh, okay, it actually moves very slowly, but it still moves. Okay, so I've quickly looked up how to expose variables from a script in Godot. And apparently there is an attribute called export instead of serialize field in Unity. And I can also remove the public then. All right, let's go back. For some reason, every time we need to hit reload here. So hopefully we can change that in the future. And apparently we also need to build every time we change something like that in the C# script. And now we can see our exposed speed variable up here. So let's raise this value to 50 and hit play again. And it moves faster now. So can we also change this during runtime? Yeah, we can, but it's a little awkward when we have to move back and forth. So hopefully we can somehow fix that. But yeah, so far this looks good. Okay, next thing I want to try is have some physics objects and some colliders, some static colliders in the scene. So let's first try to add some static sprites to act as our level, as our colliders. So let's add another child node maybe here. This should probably also be a sprite 2D so that we can see anything. And let's call this ground. Okay, here we can assign a texture. Okay, here we have a bunch of options. So maybe there's something like the procedurally generated texture, a placeholder texture. That sounds interesting. Let's use this for now. Okay, and yeah, this created a very small sprite with a purple magenta color. Let's just use this as our ground for now and look for a collider component, if it's actually called something like component here. Maybe it's something here. Maybe we have to add it as a child node. Yeah, that looks good. Collision shape 2D. Let's add a child node with a collision shape 2D here. As a warning, collision shape 2D only serves to provide a collision shape to a collision object 2D derived node. Maybe the ground will need to be a rigid body 2D, a static one that is. Let's try to create this one. Okay, what does it say here? This node has no shape, so you can, okay, consider adding a collision shape 2D. Okay, so here under the rigid body, we can add a collision shape. And now we have to create a shape here or assign one. Okay, yeah, and here we can select a new rectangle shape 2D. So let's see what that is. I accidentally moved the child object here, I think. Seems kind of hard to actually move the rigid body for some reason. Oh, there is a static body 2D I just noticed, so that's probably what we want. So actually the ground should inherit from static body 2D. I'm not sure how to do this yet, so let's get rid of this and create a new object, static body 2D. Let's rename this to ground now, and let's add a collision shape underneath, which is also going to be a rectangle shape. And now we should be good to go. Okay, again, it's really hard to move this thing, so there has to be some better way. So maybe you can add a sprite, because now it doesn't really have a visual representation. So we probably need some kind of sprite component. The question is, should it be underneath this, or should all of this actually be a child of a sprite 2D node? Let's try to add one here. So now this would be underneath the static body 2D and as a sibling of a collision shape 2D. Okay, so here in the sprite, we again assign a new placeholder texture. We can scale up to kind of match this whole thing maybe. So again, Godot only lets me drag around the collision shape, but not this entire thing here. Move mode. Oh, yeah, okay. Maybe that was the key to it. So there are, I was in select mode, and there are object manipulation modes, move, rotation, and scale. Yeah, maybe that was actually the reason. And I can probably also use scale mode, which is S instead of E, to scale this entire thing. So this should serve as a static ground object now. And let's try to do the same thing with the dynamic rigid body. So again, here we can add a sprite 2D. And yeah, place it somewhere along here. And this, in my theory, should now fall down and collide with the ground. Let's see what actually happens. Yeah, it does actually work. Okay, no idea if that's kind of the intended structure of setting this thing up. But yeah, to me, it's the first thing that came to my mind and the first thing that actually does what I expected to do. So next thing, try to make a very simple character that we can actually move around using a rigid body and maybe even add a simple jump mechanic. Or rather, let's create a new rigid body 2D to serve as the base for our player. And I'm gonna add a sprite node as well as a collision shape 2D node. For the sprite, we are using the icon. Can I actually just drag this in here? Yes, I can. And the collision shape should be a rectangular shape again. And finally, I want to create a new script called, let's call it player controller. And actually, I think since I'm using C#, I will also resort to the proper like Pascal case naming convention of C#. Since this should be a very basic character controller, we need some kind of input detection. And so far, I have no idea how to do it, but let's try if we can maybe figure it out on our own. I'm just typing in input, maybe, yeah, already it looks there is a similar way of doing input than the old input system, input manager rather, in Unity. Get axis, get vector maybe. Okay, let's head back to Godot and try to find some input manager or something like that, maybe in the project settings. Yeah, there's an input map actually. Okay, that actually looks similar to the new input system on Unity. We can add a new action. Let's call one move. And what can we do here? So what if I hit plus here? Yeah, okay, I can add a new binding, I think. So there doesn't seem to be a kind of combined composite way of defining these directional movements. So maybe we actually have to define every direction manually. Let's call this move left. Create another action, move right, which we'll bind on D. We could also add another binding for the arrow keys. Yeah. So this is basically working very similar to the Unity input system, where we can just define for each action a list of different bindings for different controller or keyboard configurations, basically. We'll add a jump action, which will bind on the space key. We can query, is action pressed? That would be for like single events, like the jump, I guess. Yeah, that looks good. Is action just pressed? Okay, yeah, that is basically the one we would want for like one-time events that we don't want to query every frame. And how do we query the value of the directional event? Action strength, I'm not sure about that. It returns a value between 0 and 1, representing the intensity of the given action. If it get an action strength, move left. So basically this would be our horizontal movement value. Horizontal equals, yeah, we can probably just add those two up, like the left movement and the right movement combined should give our horizontal movement, which would be either we move in the left direction or we move to the right direction. And we can basically just use a code similar to our move sprite here and move the position, although now we are actually running on a rigid body 2D, so we would actually want to set the velocity. Let's see if there's something like a velocity. There is a linear velocity. Okay, here it says something about physics running in another thread and runs at a different granularity. So this would be something that we would use in Unity's fixed update. Use integrate forces as your process loop. Okay, interesting. Integrate forces. Aha. Okay, so that's kind of the fixed update method equivalent, I would say. So here we should set the linear velocity on linear velocity. Yeah, we can. In the process, we want to receive our current input values. And then in the integrate forces method, we want to apply it to the rigid body's velocity, right? So let's cache the horizontal. And then in the integrate forces, we want to apply the horizontal times some kind of speed value, which we want to expose, or rather export, some default value. And the y component we leave at 0 for now, or actually at linear velocity dot y, because that's the kind of the gravity part that is automatically calculated by the rigid body, right? We don't want to override this. So this should be kind of horizontal movement only, if I'm not mistaken here. We need to build again here. Finally here, yeah, here we can see the speed. Yeah, let's move the player a little bit closer to the center. And then let's see if there's actually something going on. Okay, I'm now hitting the right key and it's actually not doing anything. So I'm probably missing something, or I can try to increase the speed. Maybe that's just set too low. Yeah, that was actually the thing. Okay, now I'm only moving in one direction, no matter which one I'm pressing. Yeah, of course, both the move left and the move right gives some value between 0 and 1. So I would have to invert the move left value in order to range from -1 to 1, right? Yeah, now it actually works. There's some rotation involved. That's probably because of some drag values of the rigid body, but in general, it does what it's supposed to. Oh, and I just noticed that the inspector values that we're changing during runtime are actually persisted, different than how it is in Unity, where they are reset back when we are exiting play mode. Let's see if we can get rid of the rotation, which we don't really want here. Kinematic, static, no. Lock rotation on, that looks good. Yeah, and finally we can add a basic jump mechanic. So for this we will use input.is_action just pressed with our action name jump. And if that's the case, we can perform the jump. Let's create a method doJump. And this is supposed to basically add an instantaneous force to our rigid body. Let's see if there's some method for that. Add force, add constant force, impulse, apply impulse. Okay, interesting. So we would have to define a direction, which is vector2.up multiplied by some jump force, basically. So let's specify another exported variable called jump force. Not sure how high that would have to be. Let's set it to 100. And call this function here. Of course, we would need some ground check because currently we would be able to also perform the jump in midair. But for now, let's just test it with the most basic setup. So now I'm hitting space. Okay, it's doing a tiny jump, so let's increase the jump force to maybe 500. Yeah, that's kind of a really basic jump and horizontal movement, so we are already getting somewhere. Okay, so before we are improving the character controller, I actually want to try to bring over some of the assets from my game Summit, see how that goes. Like how to build a basic environment, how to add some background elements, and maybe even some of the character sprites. Okay, so I've copied a few of the assets just in the file system, basically. And the file explorer here automatically recognizes all of the files, which is pretty nice. So for the character, I have actually exported it as a PNG for now without any animation. I've actually used the PSB importer of Unity, which is obviously not supported in Godot yet, but I will probably try to export it as a sprite sheet with all of the individual body parts and then try to add skeletal animation, which apparently is a thing already in Godot. And for the tilemap, we have this little thing here, which there definitely is a tilemap support in Godot, which I'm also very curious to learn about. And there are two backgrounds, basically, which I can probably just add right away to the scene here. So just a few static images, basically. Okay, now obviously they are hiding all of the objects underneath, so let's try to figure out how the sprite ordering works in Godot. There's a tab ordering, which looks good. C index. Okay. And yeah, let's try to figure out how the tilemap system works in Godot. Let's see if it's actually that user-friendly that I'm able to figure it out without looking up any tutorials. So I would assume that there is maybe some node for this. Tilemap, yeah, of course there is. Okay, so we have a tile set here in the properties, which we can create a new one. New tile set, okay. Suddenly here we have a bottom area, a bottom pane, which has, I think, the tile set configuration. No tile set source selected. Select or create a tile set source. You can create a new source by using the add button on the left or by dropping a tile set texture onto the source list. Okay, that's very nice. Let's try to drag it here. The atlas texture was modified. Would you like to automatically create tiles? Yes, I would like to. So those are definitely too small. Let's see how we can increase. Okay, here, texture, region size. Probably that's the one we want. So I think my tile set was 128 then probably. Yeah, that's the one. Okay. I mean, that was surprisingly easy if that was all there is to it. Now, can we actually already start to add tiles here? What's going on with the selection? Setup. Okay, we are still in setup mode. Maybe we should go to the paint mode. Okay, here we go. Cell quadrant size. We also probably need to set this to 128. Or do we? Couldn't see any changes there. Okay, what else would we have to set up here? Maybe, I'm not sure if I have to do anything here. Can I drag in something? No, I can't. Oh, now I'm in a different mode. There needs to be some kind of paint tiles tool, I think. Maybe here. Okay, now this one looks different. So now we have a line, a rectangle. Okay, but here we are in a paint mode. So down here it looks fine, but I need some other mode up here, I would say, in the scene view. Oh, okay. So the select mode seems to work. Oh, okay, yeah. This works, but it's way too big. So let's see what's going on here. So cell quadrant size, I set to 128, which is, I don't know. It was 16 before, right? But that's not even related, I think, to this view here. Tile size. What is? Oh, okay. I think that's the one. Yeah, that looks good. Okay, so that's actually the tile size for the scene. But now we can actually draw tiles here, which was pretty straightforward to set up, I gotta say. Okay, for some reason I cannot use all of the tiles. Oh, okay, now I get it. Here we have a tile set and a tile map. So the tile map is basically for selecting tiles to draw onto the scene, and the tile set is for setting it up. So here I have made some mistake apparently, but I'm just selecting all of it for now. And now I can probably select all of them, yeah, during this mode as well. So yeah, with the rectangle mode, I can draw up a rectangle and create a bunch of tiles here. Okay, this actually feels really nice and intuitive, I would say. Let's see if that already has a collision enabled in some way. It probably needs to be done in the tile set as well. After all, not all of these tiles should have a full box collision. Well, let's actually start the game and see what's happening. I assume the character would just fall through. Yeah, okay. Okay, if I'm going to select mode, I can select individual tiles and there is animation. Okay, so there is actually tile-based animation, rendering, terrains, physics layers, add element. Oh, okay, here we have some kind of collision matrix. similar to the collision matrix in Unity's project settings, I assume. Oh, okay, and suddenly I think we have got a physics section here. I think this wasn't here before, so probably we needed to add this element here to the physics layers. Okay, fair enough. So now we can add polygon tool. Okay, we can define a custom physics outline, I think. Oh, okay, I got it. How can I add like a full box? That would be, I think, desirable here. Can I actually remove this? Clear. Reset to default tile shape. Yeah, that's the one. Okay, interesting. So I probably want to select all of the tiles here and go to reset to default tile shape. Not sure if that was actually saved. I'm not sure. Let's hit play and see what happens. Okay, it actually worked, it looks like. Force show. Oh, okay. If I'm going to force show, then I can actually see the collisions. Okay, I mean, if everything is set up correctly, it's probably not super useful to see the collision outlines all the time, so I kind of get it. Okay, but setting up the tile map was actually pretty straightforward. The physics thing was a little bit weird, but other than that, I'm pretty happy with it. So let me add a little bit of environment here. Maybe resize the player a little bit. Got a warning now. Size changes to rigid body 2D will be overridden by physics engine when running. Change the size in children collision shapes instead. Okay, that makes sense. So we want to actually change the size of the sprite and of the collision shape here. And now that we have our static character image, character sprite, we can actually also swap this placeholder here with that one and scale it down accordingly. Of course, next time we want to replace this character with 2D skeletal animation anyway. So for now, the sprite is just a placeholder. So let's hit play one more time. And yeah, we have a very basic moving character that can jump around. And we have a simple tile map. The tiles are still a little bit too big, so maybe there's a way to resize the entire tile map without changing the original texture. But for now we are good. Alright, so I'm pretty happy with my very first steps in the Godot engine. We first got familiar with the editor, started by making a sprite move along the screen, added physics and collision. Then we added basic player input for horizontal movement and jumping. And finally we checked out the tilemap system and built a basic environment. Of course, we barely scratched the surface here. I'd love to turn this into a series and gradually implement more of the features of my game Summit. And this way you really get to learn the Godot engine. Hopefully this is in some way useful to you Unity devs out there who may be in the same situation of starting with Godot. I think it's really fun to learn a fresh new engine, and I can't wait to go really deep with this. See you then.